is Becca.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV.
So mass is the quantity that all of us are forever confusing with weight. And in many senses, mass and weight are really similar things. We think of mass as being how much we weigh, but there's a slight difference there. Mass really describes how much stuff is in something. And I know that probably doesn't seem like a very good definition, but an easier way to think about it might be to think that here on the Earth, your mass and your weight are the same. But on the Moon, your mass would still remain the same, but your weight would actually be lower because the gravity on the Earth, or the gravity on the Moon, excuse me, is lower. And so weight is actually mass times gravity, and mass is just the property itself, the characteristic of the stuff inside of something else. The mass of all things comes from the nuclei inside the atoms that make up those things. So what we're going to do today is just look at how atomic mass, the mass of an atom, is calculated. And we'll look at some examples of that and see what an isotope is as well. If we could jump to my screen really quick. So to start with, we need to think about what an atom is. We've been over in other videos the different parts of an atom, but I'll just draw really quickly here a simple diagram of an atom. Oops, let me try that one more time. OK, so an atom, the center of an atom is called the nucleus. The nucleus. And the nucleus contains protons and neutrons. So I'll just put a P and an N inside of the nucleus. Now, protons are positively charged, and that's important when we're thinking about the net charge of something, which we'll talk about in another video. But for today, we're just going to be thinking about mass, and so we don't need to necessarily think about those charges. There's another subatomic particle, the electron, which has a negative charge. Electrons are located in what are called electron orbitals, which are regions of space that are found outside of the nucleus or surrounding the nucleus. In diagrams, we always draw the electron orbitals like this as rings, kind of just outside of the nucleus. And we call these areas orbitals because it's easy to see that the electrons sitting on those orbitals sort of look like planets orbiting the sun. But this is actually sort of an inaccurate way of describing what an atom actually looks like. Atoms themselves, what they actually look like is much more complex, and the distance between a nucleus and an electron is actually much greater than is shown in this diagram. But this diagram works for our purposes today. So again, these little balls here represent electrons. OK. Now, electrons actually don't have any mass. That's not perfectly true. Electrons have a very, very, very tiny amount of mass, and if you get enough of them together, like all of the electrons that comprise all of the internet, you can get a very, very small amount of mass, of measurable mass. But the majority of mass of anything comes from the protons and the neutrons within the atoms that make up that thing. And so it's really protons and neutrons that provide the mass for an atom. So we say that a proton and a neutron both have the weight of one atomic mass unit. And the atomic mass of an atom is always calculated by just adding the protons and the neutrons together. Let's take a look at a specific element example to see what I mean. A lot of times to use a periodic table, I use the website ptable.com. It's just a really good open source, free to use periodic table with lots of information. To think about the mass of an atom, let's think about carbon, which is one of the most common elements, and indeed it's the most common element in living organisms, the backbone of all molecules that make up living organisms, so a pretty important molecule. Carbon, as you can see here, as I hover over it, you can see that carbon has, well, let's go back to our screen here and let's actually draw a carbon symbol. So in this box here, the symbol for carbon on the periodic table looks like this. There's a 6, and then a C. Oh, that is an ugly C. And then it says carbon. And then there's a number down here, 12.01. OK, so in a periodic table symbol, the top number is always going to be your atomic number. And the atomic number always tells us the number of protons. The symbol here, the C, is just the symbol that represents carbon. So we'll use C to represent carbon in different kinds of molecular diagrams. Oops, let me finish writing atomic number. And then down below here, we have the atomic mass. Oops. Let me see if I can get there. OK, this is the atomic mass. And the atomic mass of an atom is always found by adding together the protons and the neutrons. Now you'll notice that the mass of the carbon atom is listed as 12.01, and that might seem a little bit confusing. We can't have 0.01 of a proton or a neutron. So atomic masses for a given atom should always be a whole number, like 12 or 13 or 11. In the case of carbon, carbon has several different isotopes. And so an isotope is a version of an atom that has a different number of neutrons. So as I mentioned before, the atomic number always tells us the number of protons in an atom. So if it's a carbon atom, it's always going to have 6 protons. Let's draw another atomic nuclei here. 6p, 6, and hopefully you can see that. So we'll imagine an atomic nucleus that has 6 protons and 6 neutrons. Because it has 6 protons, this atomic nucleus must be the nucleus of a carbon atom. Okay, so this would have to be carbon. Yep. And the weight of this carbon atom would be 12, because we find the weight, or excuse me, the mass of an atom by adding together the protons and the neutrons. See, I just did it. I used weight instead of mass. We're perpetually doing that. Okay, but there are other isotopes of carbon. In other words, there are other versions of carbon. Let's take a look here at one of the most common versions of carbon that exists, one of the other most common. So again, 6 protons, but let's imagine a carbon with 8 neutrons. Okay, now this is still carbon. It has to still be carbon because it has 6 protons, but because it has 8 neutrons, it's not carbon 12, it's carbon 14. It's a carbon atom with a mass of 14. Okay, now the vast majority of carbon that exists in the world is actually carbon 12. But there are some examples of carbon 13, which is going to be carbon with 7 neutrons, and carbon 14, which is going to be carbon with 8 neutrons. And those small amounts of carbon that we've measured in the world, when we average the weight of all the carbon atoms in the world, the average that we get is 12.01. And that is why this number here, where's my marker? That is why this number here is not just 12, but it's 12.01, because it's actually an average of all the different isotopes or versions of carbon that exist. So I'll just give one last little piece of information here. Oftentimes in a class, you're asked to calculate the number of neutrons in the most common isotope of a given element. So let's just pick one element at random. Oh, those are thicker borders than I intended, but that's fine. We're going to pick another element from the periodic table here. Let's pick a more random one. Let's do nickel. Oops. Okay, so nickel, if I look at nickel, nickel's periodic table symbol, or square, has a 28, and then the symbol is Ni, and its atomic mass is 58.693. So let's jump back here, and I'll go back to black, and let's see, it was 28, nickel, and what did I say? I better check again. I think I said 58.693, okay. 58.693. Okay, so the average of all the different nickel isotopes that we've seen, the weight of them is 58.693 atomic mass units. But to figure out the most common isotope, all we need to do is round that mass number, that atomic mass number, to the nearest whole number. So the nearest whole number for 58.693 would be 59. 59 is going to be the mass of the most common isotope of nickel. And then to find the number of neutrons that a nickel atom would have, all we would have to do is subtract the number of protons. So to find the number of protons in nickel, we merely have to look at the symbol. Nickel symbol shows us nickel is the 28th element. It's got the atomic number 28. And so that means that all nickel atoms are going to have 28 protons. All right, so all we do then is we just subtract the protons from the mass, and we get, let's see here, what would it be? 31 neutrons. Oops. Hold on. Oh no. Hold on, folks. Having some trouble with my board. Okay, protons. Oh, there's my line. And neutrons, not misspelled. Okay, so to find the number of neutrons in an atom, of the most common isotope of an atom, let's say, or of an element, all you would need to do is find that number or find that element on the periodic table, find its atomic mass number, round to the nearest whole number, and then subtract the number of protons. So hopefully this helps a little bit with figuring out what atomic mass is and how it's calculated.